Okay, so I just checked, and I did state the problem correctly, so we can continue on with our resolution without spoiling it. But the reason you can ask either, because you don't know who is who, you can ask either of the guards what the other guard would do, and then you do the opposite. Because if you ask, you don't know who you pick the person A, just whoever you pick, and he happens to be the person that only tells the truth, and you don't know that. So if you ask him what the other person would do, he's going to tell you the truth. And so if person A tells you the truth, and he's the truth teller, he's going to tell you that person B would tell you a lie. And so you would go down the path that's opposite of what person A told you, because he would be telling you what the liar told you. And so you would be able to go down the path with the water. If you happen to ask the liar, who lies every time, what path to go down, what would happen? Well, he would tell you a lie. So he would tell you the opposite of what the truth guy would tell you. So if you do the opposite of what he says, you're going down the right path regardless as well. So if you ask either guard what the other guard would do, and then do the opposite, then you go down and you get your water and you get to survive. So what is that? Right? In the same way Google says, a paradox might have some underlying truth. I think that there aren't any paradoxes that don't even exist. Again, as I said, I think it's internal confliction or internal genuine ignorance, not like you're ignorant and arrogant. Again, I always draw a huge line between ignorant and arrogance. Ignorant just meaning you genuinely don't know something. Ask a question, learn, be open to it. Arrogant meaning you confidently don't know something. Or you do know something and you're just a dick. but that riddle or that thought experiment or that logical unwinding really does is that you have states, you have conditions, right, where you don't know which guard's going to tell you what, and you get the same outcome. And so in the same way we can immediately go, when I do in my paper, is showing you that the microstates, I introduce something that's called entropic potential, just again, entropy of a system, how many subspaces does a physical system have? And I discussed this in one of the previous episodes, saying that it's like having a big house. The bigger your house, the more ways you can be disorderly. And entropy is a tendency to disorder. And entropy always increases over time because no physical process is efficient, 100% efficient. And so the universe tends to entropy over time, more disorder. But just because you have a bigger house doesn't necessarily mean that you're going to be more disorderly just because you have more space. If you're a tidy, diligent person and disciplined, you can keep your house space even though it's bigger than someone who's a slob and lives in a smaller house. And so it's more likely that if you have more space, it's going to tend to disorder faster, but it's not guaranteed just because of the bigger space. And so that was the physical empirical basis for the logic to say that you can have, again, indiscernible states. You don't know what, if the guy is telling you a lie the whole time or the other guy, if you picked the truth teller or the liar. But what matters is you get the same result. And so I don't think logical paradoxes exist whatsoever, because I just think you can't, in the same way all we're doing, everybody speaks in fundamental theorems all of the time, it's just adding specificity is what provides value or novelty, or speciality, newness, differentiation. There's no paradoxes in general, and that you can have physical systems and logical systems in indiscernible states where you have a definite outcome. And so, again, can you put numerics to that? Again, is it 2 choices to 1 outcome, 3 choices to 2 outcomes? But again, you can have the physical containment statement of 3 is bigger than 2, 4 is bigger than 3. So anytime you have a rank of a set that is larger than the other one, you can always map the other one. But then, to end this episode of logic, to me, that logic is clear as day. I can't argue it. But then I have another thing that's clear as day that I can't resolve it. And it creates a contradiction. So do we have a physical paradox? And so you can't give more than 100%. You went to soccer practice and your buddy looks over and he's like, yeah, man, I really tried hard today. I gave it 110%. Not physically possible. And again, if I have my notebook here and I'm trying to divide it, I can't divide it more than 100%. I can't divide something that's not there. And so we talked about how you can't divide by 0, but my intuition kind of tells me, again, numerator, you start with something, that's the basis, and then you're dividing it, and you can't really get to 0 because there's a measurability limit. And so those fractions, again, you're deriving to the infinitesimality limit, and we're representing that by something called fractorial, just indicating the physical world, as opposed to factorial, the mathematical representation of a fractorial. But what do we, what was I going to say? I just lost my train of thought. But, okay, so you can't give more than 100%. So you have 1 over 1 equals 100%, but then, like, again, on like a stock appreciation, you can have something start at $10 and go to $100, so you've increased 1,000%. So you can't give, you can't divide, you can't reduce, you can't root past 100%, but you can gain more than 100%. So again, that kind of like is like the physical intuition as to why we have exponentiation, why things grow faster, why we have Taylor expansion approximations for slopes, or we approximate linearity at a given point with derivatives, with Taylor expansions. It's just I'm missing some piece of intuition again. And I already had to have resolved this to solve speciality. So again, just forcing all of this logic, putting my hands to the fire and saying, really, where's the error in my own logic? And it's not error; it's just less specificity. Again, it's like, you build up this part of your house and this part of your house and this part of your house, and now your deck's bad. You go build that up, and now the kitchen's dirty, so you go clean that up, and you have to just keep running around and cleaning up your house. I already used that analogy, but that's literally what I'm doing, word by word. And I haven't read these specific things that I reference myself in years, while doing tens of thousands of more theorems, tens of thousands on the bare minimum that I've written down. Okay, but I'm going to end that there. Do paradoxes genuinely exist, and why is there some sort of, what is the physical intuition between 100%? Division in fractions. Numerator basis, you start with a physical object, you divide it. You can't divide it more than 100%, but you can appreciate something more than 100%. Something can double, triple, quadruple its mass. So something to gaining, to progressing, to forward-looking is you can go more than 100%, but you can't go back, you can't reduce 100% or something. Again, I don't know what to say about that, but that keeps jumping out to me as that is not ironed out completely. So thank you for watching, and I will see you on the next one.